Once again, hello everyone. Thank you for joining us today for the first of our winter landscape and turfgrass webinars. We had hoped to be meeting in person earlier this week at Landscape Pro University, but Reed and Dirk from Hunter Industries were gracious enough to offer to do this as a lunch and learn, and then we'll all get back together later this year in person. But we want to thank you for being our first presenters, and we also want to thank you Hunter Industries for being a seed sponsor, which is a sponsorship of Urban Ag Council above and beyond your membership in the association, which supports many of our workforce development initiatives. So with that, Reed, thank you so much for presenting, and if you share your screen and get started, thank you.
All right, thank you very much, Mary Kay, and welcome everybody. Thanks for joining us today. My name is Reed Garner. I am a sales manager for Hunter. I'm here in the Atlanta area and I cover the Southeast region, mainly for the specification market. I have some other responsibilities. And then I've got my counterpart here, Dirk Hessman, who is our field service manager. So when you guys have issues out in the field and you need some expert hands on that project, Dirk's your guy. So he's a good guy to know. He gets me out of a lot of binds. So today we are, like Mary Kay said, unfortunately we weren't able to get together in person, but I'm looking forward to getting together later on in the summer, and kind of as a result of a good thing that we didn't do it. My daughter actually woke up this morning and had a fever, so we've got those at-home tests, and we swabbed her this morning. So my daughter has COVID, so the kids are both home from school. So if somebody's recording this, hopefully they'll leave me alone, but they were supposed to be in school right now, but there's a possibility either my daughter or my son may come into my office at some point in this, but I told him that daddy has a very important call and to not mess with me, but she's feeling okay. She's just a little snotty and got a little fever, but she'll be all right. So anyway, what we want to talk about today is smart irrigation. And we hear that term a lot, right? You know, a lot of manufacturers use that term, hey, smart irrigation. It's Smart Irrigation Month in July for the IA. What does it really mean? And I think there's sort of been a trend in the industry for the last, handful of years, especially with all the new technology that's coming out in the realm of controllers, that controllers get all that glory. A controller is a smart controller, and it can do all these things, and it can save you water and adjust the schedule and connect to the internet. And you can connect to it with your phone and do all these cool things. And that's great because those products are great. Hunter sells tons of them, and they're a very important product for us. But smart irrigation goes beyond that. In fact, it really sort of starts before the controller. I think I saw Greg Huber was on here, but me and him were having a conversation one time, and I kind of just said that, putting smart irrigation controller on a system is great, but if it's the system out in the field is not up to standards, it's kind of like that old saying, we're putting lipstick on a pig. So we want to start out in the field and make sure that that system out there is as efficient and has the most proper water saving devices as possible before we put that smart irrigation controller on there. Then we've got the best of both worlds, and we've got a very extremely efficient system that's going to save a lot of water. So really what this presentation is more geared towards is what can you do before installing a smart controller to get the most out of your irrigation systems? What are the things that you need to be doing anyway, regardless if you have a smart controller or just a regular standalone controller, to make your system efficient. So what we are going to talk about today is we're going to kind of talk about some components for smart water management, check valves, pressure regulation. You hear all these terms a lot, rain, weather sensors. Then we will spend some time talking a little bit about controllers and accessories. But really the main focus is going to be those devices out in the field. And then I want to talk about what are some best maintenance practices that you need to be doing every year on a regular basis with your irrigation systems to keep them in peak operating condition. This slide here, I put it in every irrigation presentation that I do, whether it's somebody who's never heard of irrigation before all the way up to people who have been doing irrigation for 30 years. And this is sort of it compares an irrigation system to the human body. So this is good for people who don't really have experience with irrigation to kind of, make that light bulb go off and say, hey, that's how everything goes together. But it also, guys that have been doing this for years, it kind of gives them a new perspective on it to be able to explain things to maybe their customer or maybe a new employee, that sort of thing. So Irrigation 101 compared to the human body, first and foremost, you've got your controller, clock, timer. Hear a lot of terms thrown around, but this is, equivalent to the brain. It tells the system what to do. These are 115 or sometimes 230 volt line voltage in, plugged in if it's an indoor controller, or if it's outdoor, sometimes it's hardwired. Then it has a transformer that steps that 120 volts down to 24 volts. And that's what an irrigation system runs off of. These range from being very simple, 4 programs, 6 stations, all they're going to do is just basically run that irrigation system on a simple schedule, all the way up to some very complex ones that we talked about on the last slide, about these smart controllers that can do a lot of things with weather data, adjust the schedule based off of weather, those sort of things. We've got both conventional wire and 2-wire controllers. So conventional wire is where you have a common wire and then one wire that runs to every valve that's out in the field. 2-wire or decoder base, you hear those two terms used interchangeably. That's when all the valves share the same 2 wires running from the controller, and they have a device called a decoder that's wired in between the wire path and the valve that tells that particular valve when to turn on. So typically you're going to see this in a commercial system. Roughly 25 valves or more is kind of where you start to see it, although there is some new technology out there that has made it more economical to do more in like the 15 zone range. So that's when you see 2-wire systems. We talked about the weather, flow sensors. We'll talk more about that. And then big buzzword in the last 4 or 5 years has been the internet control, the Wi-Fi controllers. Previously, that was kind of limited to real commercial properties and more expensive controllers, but that's now been brought to where it makes sense to do on a residential level. So controllers range, they run the gauntlet from simple to complex, but at the end of the day, they're the brain. They're what tells your system what to do. The field wiring is your nervous system, and that's just the wire that runs from the controller to the valves, direct burial grade. It's typically 12 to 16 gauge, depending on how far you have to run. The valves are the heart of the system, and they're operated by a 24 volt solenoid. So that 24 volt signal that's coming from the clock, that 24 volt solenoid is activated by that signal. Placed in boxes for access and service. So that's so, you can get to it if it needs to be serviced. You don't have to dig down, and it's sort of a location marker too, right? So, there's a valve box. I know these are where my valves are. The piping is the vein. So that's what moves water from one part of the system to the other. Here in Georgia, 99.9% of what we use is PVC. Up north, where they've got colder climates, you will see some polyethylene, but down here, you hardly ever see polyethylene, except with the swing pipe that goes from the sprinkler to the joint down in the PVC pipe. And then the sprinklers are the muscles. They're what do the work. They put the water out. You've got rotors, which cover large areas, fixed sprays, misters, some folks call them, cover smaller areas. You've got multi-stream rotating nozzles, which those are the ones with the fingers that move. Everybody thinks they're so pretty. Well, not only are they very pretty, but they're very efficient as well. And they have matched precipitation no matter what the radius is or the arc is. So they're real easy to design with. Then you've got drip and micros. So that's drip line, micro sprays for like pots and planters, that sort of thing. So really sum it up, this is how an irrigation system compares to the human body. That may have been a little remedial for some of you on the call, but like I said, I always like to kind of take a few minutes and go through that. So what is smart control? Well, the EPA defines that in terms of a controller as a controller that estimates or measures depletion of available plant soil moisture in order to operate an irrigation system, replenishing water as needed while minimizing excess water use. That's a fancy way of saying that it uses weather data to adjust the program based off of what's actually happening with the weather. So if it's hotter and drier, it's going to water more. If it's cooler and we've had some rain, it's going to water less. At the end of the day, that's kind of what that means. If you've got a job where it says that, we need a smart controller on this, if you're bidding a job and a landscape architect says, I want a smart irrigation controller. If you find one with this label here, the EPA WaterSense label on it, you'll know that it meets that criteria. It meets what the EPA considers a smart controller. But like I said, for optimum results, it is important that the system utilize proper design, installation, and maintenance. So that's straight off of the EPA's website, or their definition of smart controller. That's sort of the central idea of this presentation, is that smart control is great, but for optimum results, what's out in the field needs to be in tip-top shape. So it starts in the field. It's only as good as a system in which it controls, and maximum water savings can only be achieved when the field components are designed properly using water efficient products. And then the second part of that is that it's maintained properly. It can be designed properly using water efficient products, but if you install that system, 10 years go by and nobody looks at that system and takes the time to check it every year, make sure there's no leaks, make sure that all the sprinklers are turning like they're supposed to be, it's not going to mean a whole lot if it's not been maintained properly. All right, let's talk about some devices that go in the field that can help you achieve this. So the simplest, cheapest one, and I think that particularly here in Georgia, here in North Georgia, I should say, is a check valve in the sprinkler head. Now, this is a simple device, and all it basically is how many times have you been walking down the street and maybe there's a hill coming down to the sidewalk and there's like a row of sprinklers at the edge of the sidewalk, and you walk down the sidewalk and that last head before you get to the edge of the property is just leaking out some water across the sidewalk. See it all the time. What that is that's called low head drainage. So if you think about it, water in a pipe has a certain weight to it. So at the lowest point, that weight is going to push water out of that pipe. So that's what you're seeing is some drainage out of that sprinkler head. Even though the system is off, it's not running, the valve's not leaking, it's that water in the pipe that's actually weeping out and causing that. So a way to eliminate that is to use a check valve in the sprinkler head. It basically is a piece of plastic with a rubber on it that seals the bottom of the sprinkler head when it's not actively running. So you can specify these to have a check valve when you buy them from your distributor, and that we send them to the distributor from the factory with that check valve installed. Another great thing is these can be retrofitted really easily. You unscrew the sprinkler, pull it out, pop the check valve in the bottom, screw it back in, you're good to go. It's really inexpensive, and it's one of those things that I think every system should have, and not every system has. If you think about all the water you're saving, if you've got a long run of pipe, 1-inch pipe that's 100 feet long, every time that system runs and then shuts off, what's left in that pipe, 100 feet long, an inch around, just drains out over the sidewalk and gets wasted. If you've got check valves in there, all that water stays in the pipe. So the next time the sprinklers run, that water is utilized out in the landscape like it should be, instead of washing out over the sidewalk and staining and causing all sorts of issues. All right, this is a real picture that I took myself at somewhere close to my McDonald's, close to my house, when the sprinklers were running one day. And the picture doesn't do it justice, because you could barely see from where I was sitting in my truck, you could barely see the building because the sprinklers were running and they were misting so bad. Here in the Atlanta area, we have, compared to other areas in the country, extremely high water pressure. And I think that's a function of the fact that our water systems, Gwinnett, Cobb, City of Atlanta, are so big and have to serve so many people. The pressures just have to be high to get all the way out. For example, I live in Gwinnett County, but I could probably throw a rock into Barrow County, Hall County, and Jackson County from the front of my neighborhood. So I'm at the very, very tip top of Gwinnett County. And so from wherever the closest pump station is, which I think is down closer to Lawrenceville, you have to account for all that hydraulic loss and all that pressure. So to get up here, the water just has to be really high pressure. My house at the street, 120 psi, which is extremely high. So sort of the result of that is what you're seeing here in this picture is misting. And we'll talk about why misting is bad, what it does. But when you see this and it looks like that movie, Stephen King's The Mist, you know, something's wrong. So this is going to be a problem that you run across time and time again here in Metro Atlanta and North Georgia. A couple ways to address that. First and foremost, kind of your first line of defense would be a point of connection pressure regulator, PRV for pressure reducing valve. So this is simply a plumbing valve or a plumbing fitting. You might go down in your basement or in your crawl space and see one of these coming in on your main water supply to your house. Well, what it's doing is it's taking that 120 psi that's out there at the street and reducing it to a more usable pressure like 80 or 60, even 40 or 50 for a residence. Same device can be applied to an irrigation system. What it does is it just reduces the incoming service line pressure for the entire system. So it's sort of a first line of defense for reducing the pressure right where it ties into your water meter for the entire irrigation system. What it's going to do is it's going to reduce wear and tear on your entire piping system, main line, valves, lateral line, and sprinklers. So it's sort of your first line of defense. It's brass fitting typically. PR is typically how it's notated on plans, but first line of defense at your point of connection. Now moving on downstream, if you want to regulate the pressure, there are devices that will regulate the pressure at the valve. So this is a cool thing to do if you want to sort of kind of tailor the pressure of each zone to what type of emission device it has, right? So rotor sprinklers typically, depends on the manufacturer, but are happiest kind of in that 40 to 50 psi range. Sprays are happiest kind of in the 30 psi range. MP rotators, multi-stream rotating nozzles, kind of sort of in the middle, maybe closer to rotors. Well, this allows you to kind of fine tune each zone to what type of sprinkler that it has. My favorite way to approach it, especially if you've got really high pressure, is to have a point of connection pressure regulator at the point of connection that reduces it down to, say, I don't know, 80 psi. And then at each valve, use pressure regulation to sort of fine tune it. So if you got a rotor zone, you maybe reduce that down to 50 or 60. If you got a spray zone, you may reduce that down to 40 or 50, just so it sort of kind of tailors the area, tailors the zone to the pressure that it needs. You'll save a ton of water. Just here at my house, I've just got a small 4-zone turf system, but I've got a pressure regulator at the point of connection, and then I've got pressure regulators at each valve. My water bill has never been more, even when I'm watering in the middle of summer, multiple times a week, it's never been more than about $180. I've had neighbors literally next door that have had $500-600 water bills. And it's because when I see their system run, it's just, it looks like that picture of the McDonald's that I showed. So all that water is getting wasted. So dialing in your pressure is like an immediate ROI. So this is one thing that I could probably, say it's first order of business when you are looking at a system. Let's say, how do we get this pressure into a more acceptable range? These are great because they don't really require any tools, and they're easy retrofit too. So if you've already got a system in the ground, it might not be conducive to dig down, break the main line, and put in a point of connection pressure regulator. But these, very simple. They just install between the solenoid and the valve. So you take the solenoid off, put this device on, screw the solenoid back on, and boom, there you go. So really easy to do, and allows you to fine tune each part of the system. This gives you sort of a visual representation of what a non-pressure regulated head or not pressure regulated head. So you just see the difference between the water droplet size. So the non-pressure regulation, you've got that misting. So it's real susceptible to the wind to get in it and kind of take that spray and take that water and move it where it's not supposed to be. Whereas those heavy droplets, those edges are very crisp and very well defined. That water is going to go and it's going to be put where you want it to be put. So you're watering your grass, that water is going to end up on the grass. It's not going to end up with the wind carrying it and getting the sidewalk wet down to the right of it. So uses water a whole lot more efficiently, and it uses less water too. I've got, I think it's the next slide. My station. There we go. So here's some quick and down and dirty numbers. And this is whether you address the pressure point of connection at the valve, or we'll talk about in a couple of slides at the actual sprinkler head using pressure regulated heads. This is just an ROI on, how much water you can save. So this is comparing two zones. One, the heads are regulated at 30 PSI. This is a spray head. So it's happiest at 30 PSI compared to just 20 PSI over that 50 PSI. So you've got an unregulated 50 PSI compared to a regulated 30 PSI. Just one zone. We've got 10 heads with 15-foot nozzles. They're running 10 minutes, 3 times a week. So each head, when it's pressure regulated, uses 1.9 gallons per minute. Each head, when it's not pressure regulated, uses 2.7 gallons per minute. This is just straight from the nozzle spec sheet. At 30 PSI, it's 1.9 gallons a minute. At 50 PSI, it's 2.7 gallons a minute. So 10 heads per cycle for 10 minutes, you're going to use 190 gallons, 270 gallons with the unregulated. So that equates to a difference of about 10,000 gallons over the course of a year. Has anybody looked at their water bill lately and seen what, like Gwinnett County, for instance, for per 1,000 gallons of irrigation water is about $9. So right there is a $10 savings. So if you extrapolate that out of it over an entire system, it's pretty easy to realize some savings there. And that's exactly what I was talking about with my neighbor's water bill versus mine. It's a really easy way to save some money and show your customers, hey, this is exactly what I can save you just by making this upgrade here. Sort of an intangible side benefit of doing pressure regulation is that it's sort of like a flow control device. How many times have we seen this when you've got a head that sticks up and then the maintenance crew comes by with their mower, chops it off, you get a geyser next time the system runs. So with a pressure regulator, it's actually still chokes that down so you don't waste as much water. The one on the left with no regulator could waste up to 30 gallons a minute, even if it's just a small little spray head. Whereas with a regulator, it kind of gets that down to about 5-6 gallons a minute. So that's a sort of a side benefit of that you can get by doing some pressure regulation. Now we talked about pressure regulation at the point of connection at the valve. Now let's move and talk about doing it at the sprinkler head. So this is probably the easiest way to do it. Just say, okay, I'm going to get 30 PSI regulated heads, put them in. That way I don't have to worry about it. And, if you can sell that to your customer, absolutely do it. It's great. But sometimes the initial cost will kind of turn some people away. So that's where you just kind of have to go back and say, okay, here's your ROI. Yeah, you're spending X now, but you're going to pay that back in a year with your water bill savings. So at the head, it regulates it down to the manufacturer's optimal specification. So it's not a pump. So if you've got 20 PSI coming in, you put a 30 PSI head on it, it doesn't magically pump that pressure up to 30 PSI. Works the other way. If you got 40 PSI pressure regulated head in, you get down to 30 PSI. Different models are available for different nozzle types. So just for instance here, the PRS 30 is 30 PSI, and that's where spray heads, fixed sprays are typically the happiest. The PRS 40 is regulated at 40 PSI, and that's where the multi-stream rotating nozzles are typically the happiest. And then the rotor, the PRB rotor is 45 PSI, and that's where it's the happiest and where it's the most efficient. So it regulates it down to that perfect sweet spot for each nozzle type. So you really want to be sure what type of nozzle you have before you pick a pressure regulated head, because you want it to be specific to the type of nozzle that you're using. All right, moving past pressure regulation, let's talk about some other components that may help you save some water. So master valve, some systems have them, some systems don't. It really depends on personal preference. I am of the opinion that I think every system needs to have a master valve, just because the small added expense initially, you get so much benefit out of it. But basically what a master valve is, it's a single remote control electric valve located at the water source, so at the water meter, and it opens only when another valve out in the system is operating. So if zone 6 comes on, both zone 6 and the master valve open. So what that does is it keeps pressurized water off of your main line, except for when the system is running. So if you think about it in its simplest form, it's an automatic on-off valve at the source at the water meter. So your irrigation system's only going to be charged when it's actively running. A couple things that does is it minimizes wasted water due to mainline break. So if you've got a mainline break, you got a master valve, it's only going to actively run when the system is running. So instead of running 24 hours a day like it would if you didn't have a master valve, it's only going to be running 3 hours a day or whatever the system runtime is. Prolongs the system life, sort of like what we talked about with the pressure regulation. But if you keep pressure off of the main line 24/7 versus just when the system is running, it just extends the life of the PVC pipe system. You're not going to be dealing with solvent weld joints failing before they should, and things like that. So it's really I think it's just one of those things that, it differentiates you. You go in and you're bidding a system, you say, hey, I put a master valve on my systems because this is the benefit that it provides. It just separates you from the pack, and it also, it's a good piece to sell, and it's a good important part of a system. There's a couple different types. Normally closed is the most common. Normally open means it's the opposite. It's open when it's not active, and when the clock activates it, it actually shuts it. You hardly see these. You really only see them on like real large systems where there is some benefit to having a charged main line all the time, because it's such a big system, or maybe there's some quick coupler valves that are being used to manually water, and you want to have pressure on the main line at all times, but you also want the ability to shut it off if you have to automatically. But by and large, here in this area, normally open, it really isn't that common. All right, flow sensing. So it's just what it sounds like. It's a device that produces a signal that tells you what your flow is on that pipe, on that irrigation system. Depending on the type of controller that it's paired with, you can get real-time flow data that can be monitored, and you can generate high and low flow alarms that can tell you basically, do I have a broken head? Do I have a broken main line? If the controller has the capability, you can actually shut irrigation down if it senses a high flow or a low flow. You can monitor your water use, and you can compare it to the previous year, or you can compare it to what you get billed by the water purveyor, because sometimes there is a discrepancy, and you may get a huge water bill, and you can go back and say, well, actually, according to my records, this is what we used. Whether or not they agree with you is another thing, but it can at least kind of give you an idea of what amount of water that you're using. General rule of thumb is you want to install this as close to the point of connection as possible, just so you get a more accurate read there. And then a general rule is you want to allow 10 times the pipe diameter upstream and 5 times downstream. So what that means is we need a straight run of pipe with this flow sensor on it to get an accurate reading. So if you have like a 90 right before it or a 90 after it, there's too much turbulence in that piping system to really get an accurate read through it. So if you've got a 1-inch pipe, for example, you want 10 inches, so 10 times the pipe diameter upstream, and then 5 inches or 5 times the pipe diameter downstream. And what that, like I said, that just makes that signal and that flow through there nice and consistent, so you get a good read on it. So flow sensing is great because, like I said, it's going to give you alarms when you have issues. So that slide we looked at with the geyser on it, instead of having to wait until your customer calls you and says, hey, I don't know if it's supposed to be doing this, but my yard looks like Old Faithful. Or the next time you're out there, you see where it's just washed out all around that sprinkler head. you know immediately that there's something wrong because there's a high flow alarm generated the first time that zone runs when that sprinkler head is broken. All right, this has been the law in the state of Georgia since 2007, I believe, that all new systems need to have a rain shutoff device. Does it actually happen? Unfortunately, I don't think so. Things have gotten a lot better in recent years, but this is one thing that this is my hill to die on in the irrigation world right here, is range. Every system should have one. And the reason that every system should have one is, number one, is they're inexpensive. They're easy to put on. And number two, it's an optics thing. Now, they save water, but there's nothing that makes me more perturbed as when I'm driving down the road in the rain and I see a sprinkler system running. Because what happens, people look at the irrigation business and they say, those guys don't know how to be efficient with water because they're watering when it rains. And so when we get into situations like we did in 2007, 2008, when we had a drought, guess who the first people that they looked to put regulations and restrictions on? Irrigation. And it's because the optics of, we don't know how to save water. So this is the cheapest, easiest way to prevent that from happening. Okay, step down off my soapbox now. We'll talk about them. So basically a rain shutoff device is, it's a piece that suspends an irrigation cycle when precipitation is detected. Depending on the manufacturer, you can adjust the amount that it's sensitive to, quarter inch, half inch, what have you, or you can adjust what's called the dry out time. So basically the way these things work is there's a little cork inside of it. So when the cork gets wet, what does it do? It expands. That's when it senses that it's wet, breaks the common connection. The wire path doesn't allow irrigation. So some of them you can kind of change the dry out time. So if you want it to not water for a day or 2 days or 3 days after a rain event, you can dial that in. A lot of them have added features, freeze, shut off. That's important, especially like in the fall when you're watering in your pansies, drops below freezing, you water, looks really pretty, looks like a winter wonderland, but it could be a legal issue if somebody slips and falls on a sidewalk. So freeze sensors are great. Some of them have ET sensing, which they can make a controller smart by sensing ET. Wireless. So here's the other part of it, is that wireless can be added after the fact to a controller without any sort of running wire or digging. So another reason that every system, I think, needs to have a rain sensor. Common sense, but if it doesn't, it's not going to get rained on, it's not going to work. So don't put it up under a roof eave or upside down like this picture here, or sideways, or any of that thing. It needs to be able to get wet, and it needs to be somewhere where it's gonna get wet for it to work properly. Believe me, I've seen some crazy stuff. I've seen one where somebody clipped it to the bottom of a gutter, so when it rained, the water would come out the gutter and hit the rain sensor. Don't do that if you can help it. So anyway, okay, the last, let's say 10, 15 minutes here, I want to kind of just talk about some maintenance things, some system maintenance that you need to be doing to keep your system in tip-top shape. Here's some tools I think that every irrigator needs to have in their toolbox. A lot of them, everybody on this call probably already has. Product catalogs, remotes, and then your hand tools, wrenches, gauges, screwdrivers, head adjustment keys, things of that nature. One thing I think, if you do a lot of irrigation maintenance work, sort of an indispensable tool is a remote. And various manufacturers have a remote specific for their brand of controller. There are some universal ones out there. And then, like we talked about with the new smart controllers, a lot of times your phone or your tablet can act as your maintenance remote as well. Now, personally, I don't like using this as a remote, because if I'm out in the field and I've got an open valve box that's filled with water, I don't want to slip and have that go down in the water. So an actual remote, in my opinion, is the way to go. But it just saves you so much time, because you can operate the system as you're walking through it, one guy can do that instead of maybe having one guy at the controller, one guy out in the field, and then on the radio or on the phone say, hey, can you fire up zone 1 real quick? Eliminates that. You see everything right there. A lot of them, for instance, this Roam XL, which is Hunter's version, is good for Dirk. Is it 1,500 feet or it's 2,500 feet? The Roam XL?
Yeah, it's about 2,500 feet.
Yeah,
And
so it's a long way if you're doing.
actually, the Roam XL is up to 2 miles line of sight.
That's
But
right.
typically, there's things in the way that
Sure.
might have trouble getting around. But yeah, 2 miles, it says. I've seen it up to 2 miles, but usually there's something in the way that knocks it down.
Yeah. So if you're doing like parkways and you're driving along a parkway, I used to work for Valley Crest back in the day, and we did a lot of parkways, and we had our remote, and we would literally get in the truck, and when we were doing system inspections, we just drive along the parkway with our flashers on, firing up one zone after the other. And when we saw a head that wasn't turned, we'd stop, we'd put our cones out, we'd get out, fix the head, and we just keep on riding down the road just like that. So they make
They're great for apartment complexes too.
Yeah, exactly. It's just I think an indispensable tool if you're doing particularly larger properties. So, definitely something that I think that you should consider making an investment in. So what are the things you need to be doing when you're out in the field? Straightening the heads, set the arc, tune the radius, especially important with rotor sprinklers, raised sunken sprinklers. We all know that, if you're top dressing a sports field or a lawn after, it can build up over the sprinkler, you might need to raise it, replace nozzles. So if you got a clogged nozzle or a broken nozzle, definitely want to be replacing and repairing those things. One big thing, and I think that, this doesn't get a whole lot of attention like it should, is balancing your rotor nozzles. So rotor sprinklers, which are the big ones that move like this with a single stream, a lot of times the nozzles aren't what we call match precipitation. And I've got a slide here in a second that explains what that is. But a lot of times you'll buy a box from your distributor that's pre-nozzled, which is great because you don't have to take the time to install the nozzle before you install the head, but they're all number 7s or they're all 3.5s or whatever they are. Well, you go out and you install the system, and whether it's a quarter arc or whether it's a half arc or whether it's a full 360, they all get the same size nozzle. And we'll talk about in a couple of slides why you don't want to do that, because the precipitation isn't matched. So this is something I think that particularly when you're putting in a new system needs to be looked at, but even when you're looking at old systems and going through and doing inspections on those, take a look at what the rotor nozzles are, because you might be able to balance those rotor nozzles. And just by doing that, it's 30% water savings right there. So you need a couple of things to be able to do that. Is you need the manufacturer's data. So this is straight out of our Hunter catalog for PGP Ultra Blue nozzles. So the way to read this is shows you the nozzle size or the nozzle number. And then it shows you at a particular pressure, which you'll notice that 45 is bolded because if you remember from earlier in the presentation, 45 is where those are happiest at and the most efficient. It tells you what the radius is, which is how far it throws, shows you what the flow is, and then it also tells you what the precipitation rate is. So you want to understand how pressure affects those. And then but particularly what you want to get out of this chart is, okay, a 3.0 nozzle is going to have a 3.0 gallon per minute flow at 45 PSI. A 6 is going to have a 6.0, so on and so forth. And why is that important? And that is because you want to select a nozzle based off of the area being covered. So when we talk about rotors, we talk about what sort of piece of the pie or what's the arc that they cover. So if you've got, for instance, on the left, if you got a rotor that covers a quarter piece of the pie or 90 degrees, you put let's say you put a 1 gallon per minute nozzle in there. Okay, that's all well and good. Well, what if you've got a rotor that's covering twice that area? It's covering a 180 or a half slice of a pie. In the same amount of time, it's going to cover twice the area as that 90 degrees. So guess what? You need to have a nozzle that's going to put out twice the amount of water because you're covering twice the area. So in a 180, you would use a 2 gallon per minute nozzle. Same principle holds true for a full 360, a whole slice, a whole piece of the pie, a whole pie. You're going to cover 4 times the area. So you want a 4 gallon per minute nozzle. So what that does is that puts out water at the same rate over the different areas. So like I talked about, what if you put in 4 gallon per minute nozzles all across a system, whether it was a 90, a 180, or a 360? Well, that 360 would be getting the proper amount of water, where you'd be overwatering the 180 by double, and you'd be overwatering the 90 by 4 times. So you see, when you just kind of do that blanket, okay, 4 gallons per minute on all my nozzles, you're really overwatering some of those areas and wasting some of that water. So quick, easy way to match the precipitation rates and save some water there. All right, another thing to look at is if you've got an existing system and you want to figure out, okay, how can I be a little more efficient, is you want to make sure you've got what we call head-to-head coverage. Basically, head-to-head coverage means if you've got a sprinkler that its radius, let me back up 2 slides, how far it throws is 2.0 nozzle, 45 PSI, radius is 34 feet. So you want to space those heads roughly 34 feet apart. And what that means is head-to-head, so one is thrown to the other. So you can see how here we've got the radius of these sprinklers is one is always thrown to the other. Now, why do we want to do that? So here's a visual explanation. Well, let's say we've got 2 heads spaced 30 feet apart, because these are, let's say they're 30-foot radius. If you were to put a catch can at an equal space in between those sprinklers, and you were to run just one, this is what that distribution would look like. So this is just the way that sprinklers, this is just the nature of the physics of how a sprinkler works, is they put out more water closer to the head than they do farther away. So you'd have way more water in the catch cans closer to you than you would further away. If we've got head-to-head coverage, look what that does. So that evens that catch can out all the way across the board. So this is why head-to-head coverage is extremely important. So if you don't have head-to-head coverage, it might be something to where you could propose to the customer, say, hey, you know, we either need to move these heads around to get better head-to-head coverage, or maybe we need to look at doing a different sort of nozzle so we can get head-to-head coverage, because this is keeping us from operating at the most efficient.
This was great information. I feel very inspired to go outside and look at my irrigation system.
Yes,
all turned off right now.
It's, you know, it's simple stuff, but it really does make a difference. It's, you know, just paying attention to small things like that can make the biggest difference.
Yeah, I hope my irrigation person won't be offended when I send this presentation to them.
Yeah.
But I know they work with you guys, so we're good.
You mind checking this next time? But yeah, the big thing I think to take away, just given the geographic location of most people that are on the call, North Georgia, is that our water pressure is just absurdly high, and that is addressing that is probably the single most important thing you can do to really reduce your water bill. And that's, you know, that's whether or not you want to do it to save the planet or to save your checkbook, it's one or the other. It's going to help with both of those. So,
well, you know, Reed, also everything that you had said, I mean, wonderful presentation. I agree with everything you said, but you know, I've had my house for 20 years, and when I first got it, I put in the irrigation, and it was very simple, just rotors and spray heads, no pressure regulation really, old electromechanical. And over the years, I've changed out the controller, changed out heads, put in check valves, put in pressure regulation, and each one of those things helped out. But if you put them all together, it's a huge difference, not just a little difference. So yeah, you can go ahead and do little tweaks and make a difference. But if you put them all in, especially if it's a new install, go ahead and do it right and get all the full benefits right up front.
Yeah, I agree. So Greg asked if we had a diagram showing how the PSI regulator on the valve works. So here's a picture of how it installs. But basically the way it works is if you think about how a valve works, is you've got the diaphragm in there that basically opens and closes to allow water to flow through. So it's a globe style. So you've got water coming in, And when the valve is off, you've got that diaphragm that's seated, that's holding the water back. When the solenoid fires, creates a pressure differential, that diaphragm lifts up a little bit and allows water to flow through. So what this device does is it basically chokes down on the diaphragm, if that makes sense, and it only allows a certain opening of it, so that reduces the pressure. Now it does mess with I don't say mess with, change the flow slightly, but it just kind of chokes down that diaphragm. So you got to be a little bit careful. And I didn't mention it when we were talking about it, but sometimes when you do a big jump, like if you have 90 PSI and you want to reduce it down at a valve to 50, that's a pretty big jump. And sometimes you'll get like some what we call chattering of the diaphragm, where it's kind of bouncing like that just because that differential is so high. So that's why when I talked about kind of doing it in stages, doing the point of connection, then doing the valves is important, because you don't want to go from 100 to 50. You want to go from 100 to maybe 70 at the point of connection, then down to 50 at your valve. So that's why it makes sense to kind of do it in stages.
One more thing that goes back with the check valves that you put in heads and stuff like that. Another big benefit that I see out of that, and especially if you have higher pressure and it's unregulated, when that water actually drains out of the system, it gets replaced by air. Air compresses itself tremendously more than water can. So when you suddenly open up that valve and start filling that air can just tear things apart a lot faster. Air can actually go up to about 2,000 PSI on an irrigation system. So if you have class 200 pipe or schedule 40, yeah, it might be able to take it for a little while, but you are just disintegrating that pipe or heads or valves a lot faster than it should be. So keeping the air out of that system by using check valves wherever you can is a great benefit.
Yeah, that's a great point. Well, Mary Kay, thanks for having us. We're happy to do things like this, and appreciate you letting us come on. And
oh, you're very welcome. I think it's just terrific information. And once again, thank you, Reed and Dirk, for your time. It was a great presentation, and we'll see you soon.
All right. Thanks, guys.
Our pleasure.
For the weekend.
Take care. Thank you. Bye-bye.